Hello dear friends, welcome to my channels. Today's discussions is real analysis, countability. So friends, we start to discuss countable set. Countable set. Countable set, any set A is said to be countable, if it is finite. Must remember friends, this portion is very important. Finite or countable infinite. Countable infinite friends. Finite means we know that cardinality, suppose A is set, cardinality is set A is equal to finite, means any value, any you can get any values, and infinite means no value, you will get infinity. So countably infinite, what is the meaning of countably infinite? Set A is said to be countably infinite if it is similar to S of its element. We can label it as A1, A2, A3, AI minus 1. Note, term countable means count the elements, that is, if we label the elements of the set, then it should be treated as a1, a2, a3, ai minus 1. So friends, it is the main meaning is that this is the set A. Suppose this is set A and this set is natural number capital N, and there is a mapping. If is the mapping, okay friends, if is the mapping, and this mapping is 1 1 on 2, 1 1 on 2. This mapping is 1 1 on 2 map. There is a bijections mapping. That mapping is called bijection mapping. That mapping is called bijection mapping. And let's see one example. 1 cross n cross 1 is a countable. How? Because I can arrange 1 cross n is equal to 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6 dot up to any values. And after that you see that 2 comma 1, 2 comma 3, 2 comma 2 comma 4, 2 comma 5, 3 comma 1. So we can label the elements of 1 cross n by placing the elements as first put those elements whose component sum is 2. After put these elements whose component sum is 3, then put from sum 4. So I can easily express as natural number. This is bijective mapping. So there is another example is 1n is similar to set of integer f such that n tends to z. 1n set of integer f such that n tends to n. Fn is equal to minus n by 2 where n is even, and n minus 1 divided by 2 where n is odd. So f is 1 1 and on 2, and hence 1 n to j. Number 2, f such that q plus 1 n cross into 1 n such that f p by q and p comma q where f is 1 to 1. So q plus is equivalent to n cross n, so it is count 1 cross and 1 cross n is countable, so q plus is also countable. This is one example. Another example is f such that 1n tends to e1 set of positive even integers. So fn is equal to n f is 1 1 and on 2. So 1n is proportional to 2e plus 1, and 1n proportional to q plus, and z 1 cross n and q comma q plus and 2z. So cardinality of two similar sets are always equal. Must remember, cardinality is two similar sets are always equal. So Cardinality of n equal to cardinality of z and cardinality of n cross n, cardinality of q plus and 2z equals to aleph naught. This symbol is aleph naught. Aleph naught. Every infinite set has countably infinite subset. This is a very important note. And every subset of countable set is countable. So every subset of countable set is countable, and every infinite set has countable subset. Must remember, this point is very important, that every infinite has countably. Okay, this is the very important topic. So what is the countability subset? I mean, suppose R is, we know R is infinite set. It is uncountable. We know it is uncountable set, but it has countable subset. Suppose Q is a countable, so Q is the subset of R. This is the example. So next we go to the result. Cartesian product of two countable set is countable. Example: 1 cross 1 cross n, 1 cross 1 cross z, q cross q, q cross z, all are countable. And result: countable union of countable set is countable. Algebraic number. A real number A is said to be algebraic over Q if it can be root of polynomial equation with rational coefficient. Example: root 2 is an algebraic number as root 2 is root of x square minus 2. So this portion is important, friends. What is algebraic number? A real number A is said to be algebraic over Q if it can be root of polynomial. Suppose I will give one example, x square minus 2. Similarly, we can give x cube minus 3 equals to 0. So 3 cube, 1/3 of cube root of 3 is algebraic number. Very simple. And another note is the set of algebraic number is countable, and every non-empty interval is uncountable. Example: a comma b is uncountable, so its superset R is also uncountable. If such that A tends to B is onto and A is countable, and F is onto, that is mod of A obviously greater than equals to mod of B. Means suppose if such that A tends to B, okay, I draw a diagram. This is a diagram A, and this is diagram. This is A and this is B. So if it is onto a map, this map is onto map. Onto map means you get every image has pre-image. Means every element of B has pre-image of capital A. Every element of B has pre-image of capital A. So pre-image means this is called image, and pre-image means all element of B you get pre-image. Means range equals to codomain. Another way we can say range equals to codomain, because suppose A is called domain, and B is called codomain. So range equals to codomain in case of onto function. In case of function, range equals to codomain. So I hope I can clear what is onto function. So obviously b is obviously b is a is greater than b when it is onto greater than or equals to when it is 1 onto. So or a cardinality of b is aleph not or finite, so b is countable or finite. Must remember friends, if a is countable, so b is countable, because bigger is countable, so smaller should be countable. Okay, and if such that a tends to b is onto, must remember is onto, and b is uncountable, b is uncountable, so if is onto, then again we get cardinality of a is obviously greater than cardinality of a obviously greater than equals to cardinality of b, and b is uncountable, b is, must remember, b is uncountable, so obviously a must be uncountable, because smaller is uncountable, so bigger should be uncountable. Next is if such that a tends to b is 1 to 1 and a is countable, then b, if b greater than equals to a, means 1 1 on 1 1 in case of 1 1 1 1 in case of 1 1. So friends, must remember, if such that a tends to b, so it is possible b is always, cardinality of b is always greater than equals to cardinality of a. So if b is countable, so obviously a is countable, because bigger is countable, so obviously smaller is countable. It may be finite or maybe aleph not. And some example of countable and uncountable sets: set of all polynomials up to degree n, set of all polynomials up to degree n with rational coefficients, that is s equals to px equal to a0 a1x a2x a3x cube an x cube, ai belongs to capital Q. As we know, a0 a1 a2 an belongs to q1 q cross up to n. So friends, you see that n times by choosing one such tuples, we can construct our polynomials. So if we take a tuple and the coordinately, if all such tuple, we will be equal to cardinality q cross q n times, and hence the cardinality of s is cardinality of q cross q. And as we know the Cartesian product finitely of countable sets is again a countable set. Hence the cardinality of A is equal to cardinality q cross q. As we know, the Cartesian product finitely of countable set is again a countable set. Hence S is countable. Number 2, set of all unit circles in complex plane with center as rational coordinate, that is s is equal to x minus a whole square plus y minus a whole square is equal to 1, and where a comma b belongs to q. So hence s is equal to q cross q. S is countable, is a set of all circles with rational radii and rational coordinates is countable. Set of isolated points is countable. Set of isolated point is countable. Derived set of uncountable set is uncountable. So friends, let's discuss what is derived set. The set of all limit points of a set A R is said to be derived set, and it is denoted by dA or a dash. Therefore a dash is dA and P such that P is a limit point of A. So set of all limit point is called limit point is called derived set. Limit point. A point P belongs to R is said to be limit point of the set A subset of R if neighborhood of P contains at least one point of A other than P, or we can say that a point P belongs to R is a limit point of A subset of R if and only if for each neighborhood n of P we have n intersection A minus P u does not equals to phi. So friends, let's draw. This is the point P, and it is belongs to a open set, or you can say a open interval. Suppose this is P, center is P, it is epsilon, and this is epsilon. So my set is P plus epsilon and P minus epsilon. So set of P plus epsilon and P minus epsilon. P belongs to this, and this is the open interval. And if A, this is my set A, and you get at least one point. Suppose one point A which is not P belongs to A. So the formula is in intersection A minus P does not equals to phi. This is the limit point formula, because you see there is at least one point. Suppose this point is x0. This x0 is called limit point of A. A point P belongs to R is called a limit point of set A subset of R if for each epsilon greater than 0 the open interval P minus epsilon and P plus epsilon contains a point of A other than P. Means P excluding P, you get a point which is excluding P. Again I will show. This is the A point, and this is the interval point is this point is P plus epsilon and P minus epsilon. This point is P plus epsilon and P minus epsilon. Okay, so it is the, we can say this is the epsilon radius. So at least one point in here. Okay, not P, it is not P. So this point is limit point. Number 6, S is equal to f such that n into z2 and set of all functions from 1n to z2. As we know, total number of function from a to b is equal to b to the power aleph naught. B to the power aleph naught. Aleph naught is this is aleph naught. What is aleph naught? Aleph naught is the cardinality of infinite countable set. Like this is the a b to the power. Suppose a, if such that a tends to b, so how many function can be possible? The possible function is mod of a b to the order of a. This is the possibility. Next, number 7, s is equal to f such that z2 tends to n and mod of s is equal to aleph naught square. Aleph naught into aleph naught equals to aleph naught. S is countable. Then S is countable, and Number 8, s equals to f such that j tends to z, s equals to aleph naught to the power aleph naught is equal to continuum means uncountable. S is uncountable. S equals to f such that r tends to e 0 comma 1 and mod of s is equal to the power continuum, so then s is uncountable. S equals to f such that r tends to r and mod of s is equal to continuum to the power continuum, then s is uncountable. And set of all sequence with entries 0 and 1 is uncountable. Set of all disjoint interval is countable. The set of all finite subsets of 1n is countable. A is uncountable and B is countable, then A dot B is countable. Sorry, it is not countable, it is uncountable. Next problem from CSIR net. CSIR net, that let s equals to x comma y plus x square plus y square is equal to 1 by n square, where n belongs to capital N and either x belongs to q or y belongs to q. And here q is the set of rational numbers and n is the set of positive integers. Which of the following is true? S is a finite non-empty set. S is countable, S is uncountable, and S is empty. This is my option. Now you see that x belongs to q and y belongs to q. So the problem is q cross q, and I have already told in here that q cross q is countable, finite multiplications. In here I have already told n cross n is countable, so similarly q cross q is equal to infinite set of countably infinite subset, every subset. Okay, you get it from in here that we have told that S is countable because cardinality of countable, we know the Cartesian product of finitely countable sets is again countable finitely, not infinitely. Infinitely is uncountable, but in here finitely multiplication. So it is q cross q. So it is, so my answer S is countable. This is, now we will go to solve next problem. Number 2, let x denote the 2 points of set 0, 1 and write xj is equal to 0, 1. For every j equals to 1, 2, 3, let y is equal to product of j equals to 1 to xj infinity. So obviously you see that it is the product of j equals to 1 to infinity xj. So product of infinite countable set is uncountable. So y is countable set, this portion is wrong. Cardinality of y equals to cardinality of 0, 1, this is correct because it is uncountable, so both are 0, 1. So cardinality of y is equal to cardinality of 0, 1. So 0, 1, cardinality of 0, 1 is continuum, and this function is also continuum, so this is correct. And union of n equals to 1 to infinity, j equals to 1 to n, xj is countable or not. Must remember friends, the product of j equals to 1 to n xj is countable. How? Because this is not infinite, it is finite multiplications, finite product. So it is countable. So this portion is countable and union of this portion is also countable. And y is uncountable, this is correct. And consider the two sets 1, this is also correct because I have already told that y is uncountable. Now Consider the two sets A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, 5. The total number of functions from A to B is the number of 1 to 1 functions A to B is, and the total number of on to functions A to B is. So friends, the total number of functions from A to B is equal to B to the power A. If such that A to B, then B to the power A, this is 5 cube, means it is 125, and total number of 1 to 1 function A to B is 5p3, this value is 60, and the total number of on to function of A to B is here the total number of onto function A to B is, we have to find out A to B. Friends, in here you see that f such that A tends to B, cardinality of A is equal to 3 and cardinality of B is equal to 5. So friends, my condition, what is my condition? I have already told, for onto function, obviously A greater than equals to B, means domain is always greater than equals to codomain. So domain greater than equals to codomain, then it is possible onto function. But in here we see that domain domain is greater than codomain, so it is not possible onto function. So onto function is 0, 60 is my 1 to 1 function, and 5 cube is equal to 125 is my total by function, because B to the power E. Next problem, friends. Next problem is also CSR net problem 2012. For each j equals to 1, 2, 3, let A be a finite set containing at least two distinct elements. At least two distinct elements, then which is countable. Now friends, at least two distinct elements, A be a finite set. So A is finite means it is countable, and union of countable set countable set is countable. Okay, no problem, I hope, no problem. So correct, because union, and after that whatever you see that b j equals to 1 to infinity and j equals to 1 to an ag. So product of j equals to 1 to n ag is countable. Now question is how it is countable, because it is the product of countable set. Product of finite product of countable set is countable. Finite product of countable is countable. So finite product of countable set is countable, and union of countable set is countable. So it is uncountable. This is wrong. And after that, e.g. product of j equals to infinity. This is also wrong, because infinite product of countable set countable table set is uncountable. And after that, ai is uncountable. I equals to 1 to infinity ai. This is also wrong, because union of countable set is simple. So first option is correct, and all must remember, friends, whatever you have learned in here, we have learned that union of countable set is countable, finite product of countable set is countable, infinite product of countable set is uncountable. In case of onto function, must remember, codomain is always less than equals to domain. In case of one-to-one function, domain is greater than equals to solve a comma b belongs to r square, a greater than equals to b. Friends, in here you see it is r cross r. R is uncountable. R is uncountable, so it is obviously correct. And r square equal to a plus b. So this is also correct, because a equals to root 2 and b equals to minus root 2, and root 2 equals to 0, and 0 belongs to q. Inherited belongs to q, so it is uncountable, because a irrational number. A and b belongs to z. Same, a equals to root 3 and b equals to root 3, so it is 3 belongs to z, so it is also correct. And a comma b belongs to q. A comma b belongs to q means q cross q, and q is countable, so it is not uncountable. Which of the following sets are uncountable? The set of all functions from R to 0, 1. Set of all function. So friends, R equals to continuum set, friends, and 0, 1 equals to b, it is 2. So the value of this 2 to the power c. So 2 to the power continuum, this is also uncountable, and n equals to n cardinality of m is equal to aleph naught, and this is also 2 to the power aleph naught. So the set of all function from n to 0 comma 1, this is also uncountable. The set of all subsets of n, this is also n set of Pn, power set of n equals to continuum. The set of finite subsets of n. The set finite subsets of n. This question is very simple. A1 equals to 1, comma 2, comma 3, etc. It is countable because subset, set of all finite subsets of n. So all the subsets of n, subsets of n is countable. So set of all subsets is also countable. So this is not uncountable. So three are uncountable. Next, some important definition. Cantor set. Cantor set is that the Cantor set is the set of all numbers in the interval 0, 1 which have a ternary expansions without the digit, that is ternary expansion in digits 0 or 2. Cantor set is a complement of an open set. Therefore, Cantor set is closed. Important properties of Cantor set. Cantor ternary set is measurable and measured is 0. And Cantor set is equivalent to 0, 1. Cantor set is uncountable. Now friends, we have to discuss very briefly that how it is measured. We are talking about Cantor set. This is the real line. Yeah, this line is 0 to 1. This line f1 equals to 0, 1, and f2 0, 1 by 3 union 2 by 3, 1. So this is divided into this way, and f3 equals to 0, 1 by 9, and after that this is 2 by 3, 7 by 9, and 8 by 9, 1. And C equals to intersection of n Fn, if since all f comma s are closed, then that implies C is closed. That implies C is closed. C is uncountable set. C is an uncountable set whose measure is 0. And MC measures of MC is equal to Fi minus total length of drop interval. So length of Fi equals to 1 and dropped interval is 1 by 3 plus 2 by 9 plus 4 by 27. So this value equals to 1 minus 1 by 3 divided by 1 minus 2 by 3 equals to 1 minus 1 by 3, 1 by 3 equals to 1 minus 1 by 1 equals to 0. So measures of Cantor set is 0. So friends, we get the value. So Cantor set is uncountable. Prove this. Measures of measurable and its measure is 0. Cantor set. Now friends, we discuss isolated point. A point P belongs to R. A point P belongs to R is called an isolated point of A if it is not the limit point of A. It is not limit point of A, that is, if there exists a neighborhood of P which contains no point of A other than P. Means, suppose A is a set, this is the A set, and this is the open interval P. This is the point of P. P may be in here or otherwise in here, but you will not get this portion is empty. So we can write this way: A intersection of neighborhood of P minus P equals to phi. A in intersection A n minus P equals to phi. So A intersection n and minus P equals to phi, where n is NBD neighborhood of P, neighborhood of P. Next move. A set A is called the discrete set if all its points are isolated points. Each point of set A is either isolated point of A or limit point of A. Closed set. A set is said to be closed if its complement is open. A set A set A is said to be closed if its complement is open. The null set phi is closed. The set Q is not closed set. The null set Q is not a finite set is always closed. Closure of a set. Set containing A is called the closure of A and is denoted by a bar. The smallest closed set. This is important mark. The smallest set containing A is called. So must remember A bar is subset of A. But when A equals to A bar, then it is closed set. Okay. Then say if every higher tens in R. If A bar equals to R. A bar means closure. If A is said to be nowhere tens in R if interior of the closure of A is empty. Interior of the closure. Now we discuss at point. Adherent point set E subset R every neighborhood of P contains of point of A. The set of all adherent points of A is called the adherence closures of A, and denoted adherent A. Adherent point is also called closure point. Important number one. All the integers is n of a set. Point of a set A subset of R even only if every neighborhood of E contains infinitely many points of A. Every neighborhood of E contains infinitely many points of E. E belongs to is a limit point of a set A subset of R if every neighborhood many points of E. Non-empty set if a non-empty subset of A of R which is bounded above and has no maximum member, then its supremum is limit point of the set A. A non-empty set subset A of R which is bounded above. So friends, what is the bounded above? Has no maximum member. Now the question is bounded above. A number eta is called bounded above greatest member means is called bounded or the greatest member of the set is greatest member of the set is if eta belongs to S and eta is that implies eta is itself member of capital S. No member of capital S is greater than eta, so that implies eta is an upper bound of capital S. Therefore x belongs to and that implies x less than equals to eta. So this set is bounded above. Okay, so it is bounded above. The finite set A no limit point. Must remember the supremum is a limit point of the set A when it is bounded above. Now bounded below is same factor is bounded below as a lower bound. Infimum is called member is called UB. Maximum member is called LUB. Okay, so if a non-empty subset A of R which is bounded below has no maximum member, then it is infimum is limit point of the set A. So limit point is infimum number. So friends, it is the same factor like the bounded above but zeta is the infimum when zeta belongs to set S and all set is greater than equals to zeta where x belongs to capital S. So Bolzano-Weierstrass theorem. Every infinite bounded set of real number has a limit point. This is a very important. Every infinite bounded set of a real number has a limit point. Every bounded infinite set has the smallest and the greatest limit point. Now every bounded infinite set has the smallest and greatest limit point. Now the important theorem is the condensation point. If every neighborhood of a point contains of an infinite number of points A, then that point is called condensation point of A. Then the point is called condensation point of A. Thus, a finite set has no condensation. So, infinite number of point of A. Suppose P is the condensation point and this is the neighborhood. Suppose P minus epsilon and P plus epsilon, and A intersection, this portion is in n equals to, we can say n equals to P plus epsilon minus P equals to infinite number, infinite. Then the point is condensation point, interior point. Interior point, the point x belongs to A is called interior point if there exists a neighborhood containing x and contained in A. Evidently, x must belongs to A. Means, suppose this is a set A, this is the point x, and this is the neighborhood n. Means x belongs to n, and it contains belongs to A. Then it is x is interior point. Next, friends, very simple. Real analysis is very easy, but must remember the concept. Follow the concept. Closed point. If every limit point of set S is contained in the set itself, then such a set is called closed set. Thus, a closed set has the derived set as its subset. Be a subset of A is closed set. Open set. If every point of set A is interior point of A, then A is always called an open set. An open interval is always an open set. Now friends, we will solve some question. Question number: the set of limit point of the set S is equal to 1 by m plus 1 by n. M belongs to capital N and n belongs to capital N is phi 1 by m. M belongs to capital N, 0, and none of these. So friends, let us fixed m belongs to capital N. Then for every del greater than 0, such that 1 minus 1 by m minus del and 1 by m plus del contains infinitely infinitely many number infinitely many elements of capital N. Hence, the set limit point is 1 by m such that m belongs to capital N. Limit point of the set 1 by n such that n belongs to capital N. Del greater than such that minus del comma del contains infinite of element of set is. Hence, 0 is limit point. Hence, 0 is limit point of the set is. Which of the following set is are open? Or the real number R is open set as every point of set and of real number is interior point. Similarly, phi is open set, but Q and Z are not open because every point of Q and Z is not interior. I hope I can clear this concept. Now we discuss important laws. Important laws. If commutative laws, A intersection B intersection. Union B union C, A union B union C is the associativity. Is the distributive. A union and A intersection B union C is A intersection B and A intersection C union. Okay, and De Morgan's law, A union B dash is equal to A dash intersection B dash. A union B dash is equal to A intersection union B dash. And A minus B is equal to A minus B, A minus C, and A minus B intersection A minus B intersection union B minus C. Relation. What is relation? Set A to B is a subset of A cross B. Similarly, a relation from set B to set A is subset of B cross A, and let A comma B and B into 1 cross A. This is a relation from A to B. Subset of A cross B. A relation from set A to set B is a subset of A cross B. Every subset of A cross B is relations from B to A, and phi is a subset of every set. Hence, phi is a relations from A to B, known as a empty relation. Theorem: set A has n element and B has m elements, then total number of relations from A to B is 2 to the power nm is 2 to the power A cross B. Function. Let's start the discussions. Function is two sets, and a subset of f of A cross B is called a function, or mapping or map from A to B if for all A belongs to B such that A comma B belongs to F of F. If A comma B belongs to F, we can write B equals to F and call in it the image of the domain, a image of the element of A under the map F. Thus F is equal to A comma Fa such that A belongs to capital A. We also adopt the notion F such that A B to say that F is mapped from A to B. So friends, it's proved that B1 and B2 means it is unique. Means suppose the map Fx F1 equals to 2 and F1 equals to 3. This is not a function. F is not function. F is not function. Not a function means it is unique. If 1 equals to 2, if minus 1 equals to 2, it is possible. But if 1 equals to not 3 equals to 3, this is not possible. Okay, I hope it is clear for everyone. Number next, let F such that A tends to B and G such that B tends to C be two maps, and G composed F, this is the, and B composed C is a map from A to C is called composition of map of F and G. Given G composed F A and G F A and A belongs to A. Definition. The subset of A cross A is called map. If A to A called identity map on A is denoted by IA. Thus IA equals to A belongs to capital A, F composed IA equals to F. And I define Fx equal to x square plus 1 whole to the power 35 for all is 1 1 and 1 equal to and a minus 35. That is the function is not 1 1. Now y is equal to the power 35. So that implies x square root of y to the power 1 by 35 minus 1. Thus the real number has no pre-image. Thus pre-image. It is so it is not onto. Neither one is correct. Next. One plus is the sum of consecutive odd integers plus u plus r. Therefore, nth one. Similarly, r is equal to r plus 1 divided by 2 equals to n. The sum of nth term of an AP equal to plus n minus 1 into d. So, therefore, p plus 1 divided by 4 1 q plus 1 divided by equals to r plus 1 divided by 2 into 2 into 1 plus r plus 1 divided by 2 minus 1 into 2. So we get the value that is plus q plus 1 whole square equals to r plus 1 whole square. This is only when e is equal to 7, e is equal to 7, q is equal to 5, and r is equal to 9. as P greater than 6 is given. You will see in here we have already in the question you get P greater than 6. This is given. So possible value is 7, Q and R. R is equal to 9. So P is equal to 7, 9. This is my answer. Next go. To solve this problem, B plus C multiple of 3. What is the last? Like P. E equal and X belongs to capital N. The possible value is 1, 2, 3, 4, 5, 6, 7, 8, 9. Possible. This is the value of A. E equals to A plus C, and where A plus B C is multiple of 3. B equals to subset of A. A plus B plus C. So B equals to AB and total possible multiple of 3 is 3, 6, 9, 15, 3 and 27 are not possible. Yet we get 6. 6 is equal to 1 plus 2 plus 3. 9 equals to 2 plus 3 plus 4. 5 plus 3 plus 1. 6 plus 2 plus 1. 12 equals to 9 plus 2 plus 1. 8 plus 3 plus 1. 7 plus 1 plus 4. 7 plus 2 plus 3. 6 plus 4. 6 plus 5 plus 5 plus 4 plus 3 this way. This is a 12, this is the 15. 9 plus 4 plus 2 9 plus 5 plus 1 9 8 plus 6 plus 1 8 plus 5 plus 2 8 plus 4 plus 3 7 plus 6 plus 2 plus 6 plus 5 plus 4 18 equals 9 plus 8 plus 1 9 plus 7 9 plus 6 plus 3 9 plus 5 plus 4 8 plus 6 plus 4 7 plus 6 plus 5 21 9 plus 8 plus 4 9 plus 7 plus 5 8 plus 7 plus 6 and after 9 plus 8 plus 7. So friends, we get such subsets according to the questions. Largest possible subset is equal to 30. You will count neither 1 nor 1. Obviously, it is neither 1 nor 1 2. Why? Why there? X is equal to cos x. Subset tends to R and fx it belongs to minus 1 this closed interval, so it is not range is does not equals to codomain, so it is not on. If you see cos I by 2 equals to 0 equals to cos 3 pi by 2, but therefore they have same image by x minus 1 and a fx plus bx minus b by x plus b. So friends, we get a square minus b square if 2a minus a minus b by 2 plus b and equals to a 2a plus b divided by 2 a square minus b square. Next is 130 and 2 into subtracting this 4 to the power n minus 2 to the power n equals to 138 minus 2. This is the I substitute. So for my convenience, I get 100 to 8. The value 2 to the power n take is equal to lambda. So my lambda square minus lambda minus 56 equals to 0. So lambda minus 8 into lambda minus 7. So lambda equals to 8. So n equals to 3. Lambda plus 7. So lambda does not equals to minus 7. So whatever we get 2 to the power n plus 1 plus a equals to 26. A equals to 26 minus 2 to the power 4 equals to 10. If 3 is 2 into 3 cube plus 10 equals to 54 plus 10 equals to 64. Answer is 64. If 3 is equals to 64, x minus 3 pi divided by 6 pi square whole square plus 4x minus 3 pi divided by 3 pi square. We can write this way. 1 minus cos minus 3 pi divided by 3 pi square, it is whole square, and plus 2 cos 4x minus 3 pi divided by 3 pi square. How friends we get? Because 2 sine square theta is equal to 1 minus cos 2 theta and 2 cos square theta equals to 1 plus cos 2 theta. This is my formula. So I apply this and I get 1 plus cos square 4x minus 3 pi divided by 3 pi square. So it can be written this way: 3 by 2 8x minus 6 pi divided by 3 pi square and period of fx is equal to 2 pi divided by 8 divided by 3 pi square is equal to 3 pi cube by 4. Answer. Next problem is equal to 1 plus sin x sine cube x sine to the power 5x to infinity. So it will be written 1 plus sine x divided and 1 plus sine x divided by cos square x. And x belongs to principal value minus pi by 2 to pi by 2. So that implies sine x equal to minus 1. So cos square x plus divided by cos to the power 4x greater than 0. So it is increasing function. This increasing function range is f minus pi by 2 comma f. So we get limit extends to minus pi by 2 x equal to minus infinity to plus infinity. Next problem. Part 0 is the sine fractional part less than 1. Also sine x less than 0. So 1 by sine part equals to 1 comma 2 comma 3 up to everything. So RF range f is equal to n. So answer is n. Next a minus sine x minus 2. So friends, we can write it is defined if and only if it should be 3 mod sine x minus sine x minus 2 greater than equals to 0. So case 1 0 sine x. So 3 sine x x minus 2 greater than equals to 0. So sine x greater than equals to 2 impossible. Less than equals to 1 only sine x is equal to 1, then it is possible. X is equal to 2 m pi plus pi by m belongs to capital I. And case 2, my minus 1 less than equals to sine x less than equals to 0, t sine x so minus sine x less than equals to half so it can be written cos x plus pi by 2 less than equals to cos pi by 3 and 2n plus pi by 3 x plus pi by 2 less than equals to 2n pi can be written 2n pi 7 pi by 6 less than equals to x less than equals to 2n pi 11 pi by 6. So friends, our domain x belongs to plus 1 pi by 2 such that m belongs to capital I, union of n belongs to plus 7 pi by 2n pi plus 11 pi by 6 equal to it will be written 2 sine 2nx cos nx 2 into cos 2nx one period of sine 2n pi by 2 pi by 2n equal to pi by n and t2 equals to period of cos 2nx so equals to 2 pi divided by 2n equals to pi by n. Period of fx equals to LCM of pi by n comma pi by n equals to pi by n equals to pi by 6. It is given. So n equals to 6. The question that has pi by 6 is fundamental. N equals to next friends next to it x minus per be written as square x minus 3 to the power x into 2 by 2 plus 1 by 4 minus 1 by 4 plus 1 will become square plus 3 by its value is equal greater than equals to 3 by highest value is x is the greater than equals to minus infinity to 1. This value will become you can write this way minus half. So friends, minimum value is 3 by 4 of this given functions and maximum value is this portion 3 minus half is equal to 5 by 25 by 4 plus 3 by 4 equals to 28 divided by 4 by 4. So 3 by 4 less than minimum value 9 to the power x minus 3 to the power x plus 1 greater than 28 by 4. This is my maximum and minimum. So greatest integer as it is greatest integer, so we can take the values are RF range of f 1, 2, 3, 4, 5, 6 range of the functions. Next friends, next we will solve question number 13. Question number 13. The question is a fx. So f dash x is equal to x square plus 2 whole square minus a x square minus 10x next plus 2a. How I get this friends? I get this, I use ddx of, must remember, and ddx of u by v equals to v squared into du by dx, v into u into dv by dx. So I get these equations from using this formula. So friends, now the equation is minus a x squared minus 10x plus 2a 2a equals to 0. So numerator means discriminant is equal to AC. B square minus AC means B square minus 4AC equals to 100 minus plus 8a square is always greater than 0. So friends, greater than 0 for all a belongs to R and numerator dot has two values of x, then it is It is many one. Next problem. T1 period of tan x by n equals to pi divided by 1 by n is equal to pi n, and T2 equals to period of sine nx equals to 2 pi divided by n. Of fx is equal to LCM of Q1 is equal to LCM of 2n pi divided by n square is equal to 2n pi divided by 2 equals to LCM of this, we get 2n pi equals to 6 pi, so n equals to 3. This is my answer. Next problem is that x square fx 2f1 by x, fx is even function satisfaction the relation this, and gx is odd function, then the value of f5. So how can I get this value? X square fx minus 2 into f 1 by x equals to gx, and after that replacing this, that f 1 by x square f 1 by x minus 2 f x is equal to 1 by x. So f 1 by x minus 2x square fx is equal to 2x square g 1 by x. So this is 1 and this is 2. Adding this 1 and 2, we get it can be written 4x square, yes, 2. So 3x square fx is equal to gx plus 3x square g1 by x. So fx is equal to minus gx plus 2x square g 1 by x divided by 3x square. This is my fx value. Now it is telling that given that gx is an odd function, so that f minus x equals to minus of fx, as gx is odd function. So therefore fx okay, f minus x equal to minus fx, so fx equal to 0, so f5 equals to 0. Here fx is even function. Fx is even function, it is already told. That's why we see that f of minus x is equal to a minus fx, so is equal to we get minus fx, as it is even function. That's why f5 is equal to 0. Very nice problem. Which of the following graphs which of which of the following graphs are graph of function? So let's see that this function, this is y and this is x. Y is equal to fx. This is y is equal to fx. This is y is equal to fx. So friends, whatever you see, that in case this is function, this portion or portion is functions, because we get unique element of y corresponding to x. How? Because friends, cuts the graph at one point. at one point, then its graph of function. If condition, if any line parallel to y-axis cuts the graph at one point, then its graph of function, then its graph of function. So friends, here you see on this point, this diagram is correct, and others all the diagram you see they are not function. So let's move to solve another problem. This problem, the graph fx is equal to 1 by mod x minus n modulus is lie in the, so where is it lie? So friends, fx, obviously fx greater than equals to 0 for all x belongs to R minus 0, and therefore we get it first and second quadrant it lie. Next problem, fx is equal to sine x to the power 7 e x to the power 5 sine x to the power 9. So if O is equal to odd and capital E is equal to even, then sine to the power 7 times 2 O and sine x to the power 9 times 2 O. So x to the power 5 is odd, so, and e to the power x to the power 5 is gn x to the power n is even, because odd into odd equals to even, and you get fx is equals to odd cross even equals to odd. So my it is odd function is odd. Next, sine 2x, obviously sine 2x minus box cos 2x greater than equals to 0, Hence we get modular box integer sine 2x greater than equals to, so box of sine 2x minus 1, 0 and 1, greatest integer. So then box of cos 2x minus 1, box of cos 2x greater than equals to 0. So we get box of cos 2x equals to minus 1 comma 0 comma 1, but mod of sine 2x, but box of sine 2x equals to 1 and box of cos 2x equals to 1, box of sine 2x equals to 1 and box of cos 2x equals to minus 1 are not possible. This is not possible because we know that sine 0 is equal to 1 and cos 0 is equal to sine 0 is equal to 0, cos 0 is equal to 1. So this combination is not possible. So possible combination is when possible combination box of sine 2x equals to 0, box of cos 2x equals to 1 minus 1, and this way we get that range of function f is equal to 0 to 1. How? Because this is the possible combination. Another combination is box of sine 2x equals to 1, box of cos 2x equal to 0. Clearly fx is equal to x square divided by box of a. So if is minus 20 to 20 tends to r, defined by is an even function. The set of values of a is given by, so we have to find out set of values. So whatever we get, x square by a equals to 0. So for all x belongs to 20 to 20, so the possibility is if the effects will be even number. If fx is even number. Even function. If fx is even function, then x square by a equals to 0. So friends, 0 less than equals to x square by a less than equals to 1, and that implies, or 0 x square less than equals to 400. So obviously less than 400, and a belongs to 400 comma infinity. Next problem is very interesting problem. Let a equal to 1 2 3 4 and b equal to abc, then the number of functions of a to b which are not on to e. So total number of function from a tends to b equals to and number of onto mapping number of onto mapping is coefficient efficient of x to the power 4 in 4 factorial e to the power x minus 1 whole cube. It can be written this way, that coefficient of x to the power 4 in 4 factorial e to the power 3x minus 3 into 2 is equal to 2x plus 3 e to the power x minus 1 equals to 4 factorial 3 to the power 4 divided by 4 factorial 3 into 2 to the power 4 divided by 4 factorial plus 3 into 1 to the power 4 divided by 4 factorial minus 0. So we get the value is 81 minus 48 plus 3 equals to 36. Number of number of not onto is 81 minus 36 is equal to 45. So friends, my answer is 40. 45 is my answer. Next problem is let fx is equal to sine tan x and gx is equal to cos inverse 1 minus tan square x are same function, then when sine inverse sine tan x equals to cos inverse cos 0 comma pi by 2 and tan x equals to cos inverse cos can be written not cos, can be written sine root over 1 minus tan square x. So 0 less than equals to tan x less than equals to pi by 2 and x belongs to 0 comma tan inverse pi by 2. Answer. Next problem number 23. Fx f into 1 minus x equals to x square plus 2, then x belongs to R. So find out. So replacing x tends to 1 minus x, get f 1 minus x. So friends, replacing x tends to 1 minus x, we get f 1 minus x is equal to 2fx is equal to 1 minus x squared plus 2. Now the equation number 2 and this is equation number 1. So I multiply 2 and subtracting minus 3fx is equal to x square 2 minus x minus 4. So it is x square minus 4x plus 4 is equal to fx 3fx. So fx is equal to x minus 2 whole square divided by 3. So this is my answer, x minus 2 whole square divided by 3. Next problem is 2 into fx minus 1 and f minus f into 1 minus x divided by x equal to 1, then fx is replacing x by 1 by x, we have 2 into f 1 by x minus f into, after putting this value, 1 minus 1 by x divided by 1 by x equals to x equals to 1 by x, and after that we get the value 2 into f into 1 minus x divided by x minus f x minus 1 equals to 1 by x. Equation 1 and 2 we have 3, this is the 2, and this is equation 1. So 3 x minus 1, so fx equals to, I can write this way, 1 by 3 into 2 into x plus 1 plus 1 by x plus 1. This is my value. I hope it is clear. Very simple calculation. Next question is question number 25. So whatever you see that 2x plus 3, 2x plus 7 is equal to 2. Then period of fx. So replacing x tends to x plus 1, if 2x plus 7 plus f 2x plus 9 equals to similarly if 2x plus 2x plus in not 9, it is writing wrong, it is 2x plus 5, 2x plus 9, and 2x plus 7 plus f 2x plus 11 equals to 2. So replacing x tends to x plus 1 and x tends to x plus 2, then we get this equation number 2, equation number 3, that f 2x plus 11 equals to f 2x plus 3, and so that period is is 8. My period is 8. It is answer. Next problem is find the range of the function fx is equal to sine inverse x square plus 1 by and cos inverse x square plus minus 1 by 2. So how can I solve this problem? So that we can write that x square plus half can be x square plus half minus 1 equals to x square plus half minus 1. Can write fx is equal to sine inverse x square plus half plus cos inverse x square plus half minus 1 and x square plus half obviously greater than or equals to half, and x square plus half equals to 0 or 1. Box of x square plus half and it's get us into here. So friends, x square plus half is equal to 0 and 1. If x square plus half equals to 0, we then fx is equal to sine inverse 0 plus cos inverse 0 minus equal to 0 plus pi equals to pi, and for x square plus 1 equals to 0, so sine inverse cos inverse 1 minus 1 equals 0 plus pi equals to pi. Answer is my range is pi. Next problem, find the total number of solutions of 2 to the power x, 3 to the power x, 4 to the power x. So let fx equals to 2 by 5 to the power x, 3 by 5 to the power x, 4 by 5 equal to the power x minus 1, and f dash x less than are decreasing, so limit extends to equals to 0 plus 0 plus equals to minus 1 infinity extends to minus infinity this, and limit extends to infinity fx equals to infinity, because all the values are infinity is going to infinity. The graph of y equals to fx cuts the axis of exactly 1. So the number of solution is 1. Next problem is let f such that r tends to r defined by fx is equal to e to the power x square, e to the power minus x square, e to the power x square plus e to the power minus x square. Then f is the value of, therefore e to the power x square plus e to the power minus x square greater than 0 to the power, and e to the power x square minus e to the power minus x square 2 of x square x to the power 6 divided by 3 factorial plus infinity, that is greater than 0. So hence fx is into function f dash x 8x. So friends, e to the power plus e to the power minus x square whole square. F dash x equals to 0. So x equals to, therefore f dash x values of x. So function fx is many 1, which is neither 1 nor is my answer. Next problem is y is equal to log 10. So that implies x is less than 1. Log 10x, that implies log less than 1. Similarly, log 10 log x greater than 0. We can say that x greater than 10 to the power log 10 log 10 x greater than 0. So similarly we can get x greater than 10 to the power to 10. So my domain is infinity to 10 to the power 10 up to 10. This is my domain. Next problem. Next problem is very common for all, that this is the greatest integer. This is represent, this is a fractional part. So x can be written as greatest integer x plus fractional part. So we can write this way: r equals to 1 to 2000, x plus r divided by 2000. It can be written this way that 1 by 2000 equals to 1 to 2000 x plus r. So this point is, must remember that this is 1 by 2000 and this is 2000 x, and this point and this point is cut because x plus 1 is equal to fractional part of x, because not integer part will be vanished, only fractional part will be remain. So the answer is x. Next we go to solve this problem. Summation r equals to 1 to 1000 half r divided by 1000. So friends, how can we solve this problem? Because it can be written into this part: r equals to 1 to 49 half plus r by 1000 plus summation r equals to 49 divided by 100. Sorry, it is not 1000. It's not 1000. It is 100. So friends, it can be written half plus r by 100. So as it is the greatest integer, so this value is 0 and this value is 51, because each value is 1. So total answer is 51. So answer is 51. How? Because divided by 49, sorry, 50 divided by 100. When it is 50 by 100, then it is 1. When it is half divided by 51 by 100 equals to 1. Similarly, we can add it and we can get it is this value. Now we can write fx equals to 6 to the power x plus 1 by 6 to the power x and 3 to the power x, plus where we apply am greater than equals to gm. So 6 to the power x plus 1 by 6 to the power x greater than equals to 2 into root over 6 to the power x into 6 to the power minus x. Similarly, Similarly, 3 to the power x plus 3 to the power x 3 to the power minus x greater than equals to 2 into root over 6 to the power x 6 to the power minus x plus 2 into 3 to the power x into 3 to the power minus x plus 2. So this value is 2 plus 2 plus 2 equals to 6. So the equals to 6. Now f1x equals to 2 minus mod x divided by 4 sine inverse. f2x cos inverse 2 minus mod of x divided by 4. f3x equals to 2 minus mod x divided by 4 tan inverse. So we can get 2 minus mod x divided by 4 less than equals to minus 1, and it is less than equals to minus 1. So we can say that so it can be say that we can say minus 4 less than equals to 2 minus mod x divided by less than equals to 4. So we can get minus 6 less than equals to mod of x less than equals to 2. So it can be written that x equals to 6 equals to less than equals to minus 6, because it can be written this way, that minus 6, if minus will vanish, then it is minus 2 less than equals to mod x less than equals to 6. So this way we get df1 equals to minus 6 to 6. Similarly, df2 means domain of f2 is equal to minus 6 comma 6, and tan inverse f3x equals to tan inverse 2 minus mod x divided by 4. So it can be written this way, d, so df equals to df1 union df2 union df3 equals to minus 6 comma 6. This is not union, this is intersection. Is intersection. So this is my answer. Now next problem. If be a function satisfying fx is equal to a to the power x root over a on the above on the basis of above information, answer the following. Let fx is equal to g9x, then the value of this. Let fx is equal to g4x, this is g3x, and the value of this, and the value of, we have to solve 5 problem, friends. Now let's start. How can we solve this problem? Number 1, fx plus f1 minus x a to the power x, a to the power x plus root over a plus a to the power 1 minus x divided by a to the power 1 minus x plus root over a, and we can write this way. This is e to the power x divided by a to the power x plus root over a into a to the power root a divided by root a plus a to the power x. This way it can be written. And after that we get this value is 1. Question number 1. Now we will discuss question number 1. What is the question number 1? Question number 1, set r equals to 1 to 1995 if r 1 by 996. The value is greatest integer. So summation 1 r equals to 1 to 1995. One nine nine six equals to if 1996 plus if 2 1996 if 3 1996 plus up to dot 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 up to if 997 divided by 1996 plus if 99 divided by 1996 plus if 998 1996 number, we can write if last number 1995 divided by 1996. This is my last member. So we can arrange this way. If 1 by 1996 plus 1995 divided by 1996. This is if. You can arrange this way plus if 2 divided by 1996 plus 1994 divided by 1996. So we can be written last portion if 997 divided by 1996. If 9999 divided by 1996 plus if 998 divided by 1996. So friends, you see that this portion is equal to x. This is 1 minus x. So this portion is 1. Similarly, this portion is x. This is 1 minus x. So 1 plus 1 up to how many times? 997 times. Times 1 plus if half. This value is 997 and this value is 997 plus if half. If half is equal to half, because if half is equal to root a divided by root a plus root a equal to half. This way we can get. So friends, the value is 997 half equals to 997. So my answer is, first answer is 997. Now we move the second answer. Second problem, okay, g5 and g5 minus x is fx plus f1 minus x equals to 1, and this problem is same type of problem. So in here you get 1996. So that should be, you have already seen in here 998. In here you get another option, that is if here in case of 19976 it is 1997. Problem is based on 1997. So you can write this way, just change 6 and write only 7. Just write in here 7. So according to the problem, it is 1997 and it is summation r equals to 1 to 1996. If r by 1997 equals to this way, I can write is 7. It is 7 and it is 1996 divided by 7. So 997 plus 1. So the value is 998. Same type of problem, friends, but digit is changed, so it is 998. So I get the value 998. Let's see number fifth problem. 2 if r by 2n plus 1 summation r equals to 0 into 2n. So it can be written 2 into f divided by r by 2n, and be written 2n minus 1, write it 2n. So this 1 by 2n, f divided 4 divided by 2n, 2n minus 3 divided by 2n, 2n minus 1 minus 2 divided by 2n, plus f into 2n minus 1 divided by 2n. This way we can write. So friends, we see that 2n minus 1, 2 plus 1 plus 1, 2 into 1 plus 1 up to n minus 1 time. Same type sampling plus if half. This is the generalizations. We get it 2 into n minus 1, and if half is plus 1. So it is the value is 2n minus 1. Same type of problem, friends. This problem is same type above problem. And now whatever they say, if the value is 2, r equals to 0, 2n, 2f into r, 2n plus 1, 1 by root over 1 plus root a. So friends, we can write this way: summation r equals to 0 to 2n, 2 of r plus r plus 1 equals to f0 plus summation r equals to 0 to n f r divided by 1 plus 1. Value is n. So n equals to 1 by 1 plus root over a. So it is 987. Comparing to this, so n equals to 987. Next is numerical based question. When the problem is fx into f 1 by x equals to fx plus f 1 by x, then the possibility of fx is equal to x to the power n plus 1. If 10 equals to 10 to the power n plus 1 equals to 1001 is equal to 10 cube plus 1. So n equals to 3. So if 20 equals to 28001. So this is the answer is f20 must be 8001. Next problem is if maximum and minimum values fx is equal to 16 minus x over x minus 1. So 16 minus x obviously greater than 0. That implies x greater than 16. 2x x greater than half. 16 minus x less than equals to 2x minus 1 according to combination theory. So x less than equals to 17 by 3. 20 minus 3x less than 0. That implies x less than 20 by 3. 4x minus 5 less than equals to 0. So x less than 5 by 4. And 20 minus 3x less than equals to 4x minus 5. That implies x less than equals to 25 by 7. So combining this, we get 5 by 4 less than equals to x less than equals to 25 by 7. So domain of, therefore x belongs to I. So therefore x is equal to 2 and 3. Domain of fx 2, 3, and range of fx 14c3 plus 14c C3, 13C5 plus 11C7. So we get 2 into 14 C3, comma 13C7, 13C5 plus 13, not 13, 11C4. Its value is 728, comma 1617. So lambda equals to 1617 and mu is equal to 728. So lambda plus e mu 1617 plus 728 equals to 2345. So friends, now now my video, my lectures is finished. I hope you can understand all of the problem. This video is very large. Thanks for watching.